Good day. In this video, we're gonna look at operators in Python. So operators are special symbols used for arithmetic and logical computation. So we will look at the arithmetic operators. They perform common mathematical operations. Some of the examples is plus, minus, multiplication, division, modulus, exponential, and floor division. Then we look at assignment operators, which they assign values to variables. Let's repeat this again. They assign values to variables. So some of the examples is equals to, plus, equals to, minus, equals to, multiplication, equals to, division, equals to. Then we look at comparison. They compare two values. Then, for example, we have equals to, not equals to, greater than, less than, greater or equals to, less or equals to. Then we look at logical operators. This combines conditional statements. We will look more into this. Remember that logical operators, they combine conditional statements. So for example, we have and, we have or, we have not. Let's look at arithmetic operators. So let's start with a plus operator. So we can say 10 plus 2. This should give us 12. So we can also add here and say plus 2 again. It should give us 14. So we're getting a 14 there. So let's check the negative operator. So we can say 10 minus 9 or 10 minus 2. This gives us an 8. So let's do the small number minus the big number. So we can say 2 minus 10. Let's get an answer from here. We're getting a negative 8. So let's look at now the multiplication. We're gonna say 2 multiplied by 2 multiplied by 10, it gives us a 20. We can also multiply negative numbers. Say negative, negative, it should give us positive 20. Or when we remove the negative there, it should give us the negative 20. So let's look at the division. So we can say 2 divided by 10, it should give us 0, something. So it is 0, 2. Let's take the big number and divide the small number. So it's 10 divided by 2. So we get a 5.0. This is a floating point number, I mean. So let's check. We can also divide negative numbers before I move forward. Let's get this answer. So this is 5.0. So we can do a lot of operations. We can divide a negative number only, get a negative 5.0. So let's look at the modulus. Modulus, it is the percentage symbol. So let me try and explain how it works. So let's say we have a 10 modulus 2. Let me comment this in case we run it, we don't get errors. So what this is saying is, it says that how many times does 2 goes into 10, and we're trying to get the remainder from there. So we're going to say it is 2 plus 2 plus 2 plus 2 plus again 2. This gives us a 10. So it goes 5 times without any remainder, which is 0. Our remainder in this case, it is 0. So let's print this and see what it gives us. 10 modulo 2. This should give us a 0. This gives us a 0. So let's check for a 3. We will run after I explained here. So what we are trying to say here, we say how many times does 3 goes into 10? So it is 3 plus 3 plus 3. So 3, 6, 9. What number do I need to make a 10? It is plus 1. This plus 1 is different from the other 3. So this plus 1, it is our remainder. So let's test this and see if we're getting the remainder of 1. So we are getting, yes indeed, the remainder of 1. So let's try with a 6. We can say 7 in this case. It's not a problem. So let's try, and let me try and explain this. So we say how many times does a 7 goes into 10? It is 1. The remainder, it is 3. So we're gonna say 7 plus. What number do I need in order for me to get a 10? It is a 3, which means a 3, it is my remainder. So here, let's say 10 modulo 7. What am I getting when I run this program? I'm getting a 3. I can do it with a 9. This one we can now do and say this gives me a 1. Why is it a 1? Because when I put a 9 here, what number do I need to make a 10? It is just 1. So that's how modulars work in Python. So let's look at the floor division operator. So the floor division operator, it has 2 backslash or double backslash. So this is a floor division. So what it does, it divides then the two numbers and it rounds down to the nearest integer. What I mean is, let's say we have a 10 divided by, in this case, let me say divided by 2. This is an illustration. Let me put it clearly. 10 divided by 2. We know that 10 divided by 2, it is 5. So let me do it with a 3. Let me say 10 divided by 3. This gives me 3.333333 up until we get a 5 somewhere in this decimal number. So what we're gonna get with a floor division, when I put a floor division, this output, it goes to the nearest integer, meaning that we no longer having a decimal there. This is what it does. So let's do another example. Let's say we have a 10 divided by a 6. This should give us, let me try and calculate this, 10 divided by 6. This gives us 1, 6666666 until we get a 7. So no, I'm trying to say 10 divided by 6, it gives us 1,6666. But if I want to get this 1 only, I have to put a double backslash there. So we remove this decimal. So let's try run this program and see what we get it. So when we say print 10 floor division 3. So what do we get when we run the program? We're getting a 3, not a 3,33333. Then when we do it with a 6, what do we get? We get a 1. This is how we use modulars in Python and in other programming languages. So let's go to explore exponentiation or exponentials. So exponential is represented with two multiplication sign or two star symbols. So when I say 10 to the power of 2, this should give me 100. This is 10 times 10. So when I say 30 to the power of 2, this is 30 times 30. So this is how we do this we do the exponential in Python. So here I would say 30, or let me do a simple number and say 2 to the power of 2. 2 to the power of 2, it is 4. So we should be getting a 4 in our output. So this is a 4. Let's say 2 to the power of 3, which is 8. Let's try and see what we're getting. It is 8. Assignment operators. Assignment operators are used to assign values to variables. So the first assignment operator, it is equals to. So here we say x, it is equals to 5. So this value, it is assigned to the variable x. It is stored into our x variable. I can say y, it is equals to 10. This 10, it is stored into our y variable. So this is an assignment operator. The values are assigned to the variable. So the second assignment operator, we have a negative and an equals to. So what this does, mostly it updates our x variable. So you cannot just start by doing this, so it will give you an error. So let's say x minus and equals to 5. So it will give you an error. So I want to show you something. It will give you an error. So why it gives us an error? Let's try to investigate what is happening. So this x negative and equals to 5, it is the same as, let me put a hash there, it is the same as x, it is equals to x minus 5. So what Python will do, will expect a value here. So that is why I said this, in most cases, it is used to update our x variable. So we have to assign our initial variable of x. We can say x, it is equals to 10. Let me put a different number and say 10 there. So what will happen here, our value of 10 will be assigned here, which will be 5 minus 10 minus 5. I mean, this will be equals to 5. So this is what this statement or expression is doing. So the 10 will be assigned here, then it will be 10 minus 5, which is equals to 5. So let's run the program and see what we get. So we get a 5. So we can do this with a plus. We can put a plus there. So what will happen here? It will be 10. This x variable will be assigned. This variable will be assigned to this variable x, which will be 10. 10 minus 5. Oh, we are working with a plus now. It will be 10 plus 5, which is equals to 15. So let's run the program and see what we get. So we get a 15. So we can also do it with a multiplication, which is asterisk. So we say x asterisk and equals to 5. It is the same as x. It is equals to this x that we initially have there. So it will be x times 5. So it will be 10 times 5, which is equals to 50. So let's run the program. So we're getting a 50. So we can use it with a division. We can use also a division. So what will happen here? It will be a division again here. So this value will be assigned to this x variable. So it will be 10 divided by 5, which is equals to 2. Let's run the program and see. So it will be 2.0. So we can also use many operators that I've mentioned previously on the arithmetic operators. So we can also use a modulus. So what will happen here? It will be a modulus here. We can also use a floor division. So here it will be a floor division. We can use as many arithmetic operators we can. Comparison operators. Comparison operators are used to compare two values. So in this case, let's say we have a 3, we have a 9. So it can be any two values. So we are trying to compare these two values and we want to get a true or a false value. So this will be useful in different computations like your if statements, your for loops. So it will depend on where you will be using it. So the comparison operators, that's where the fun of programming takes place, and that's where gaming, all that, they use a lot of comparison operators. So for mathematics also, so it's interesting. So let's get to it without wasting any time. So the first operator that we have, it is equals to. So this compares two values if they are equal. So let's say we have an x, it is equal to 2, and we have a y, it is equals to 3. So now we want to compare these two values. So we say x is equals to y. So in this case, we are lying. 2 it is not equals to y. So what we're gonna get, it is a false value. So this, we're returning a false value, but if I put a true there, we will get a true value. So 2 it is equals to 2. Then the second assignment, comparison operators. I like switching the words comparison with the assignment. The assignment operators, what they do, they assign values to operators. Then comparison operators, they compare two values. So this is very, very important. So if you understand this, then coding or programming becomes easier. So now we have a not equals to y. So we say 2 it is not equals to y. No, that's not true, because 2 it is equals to 2. So in this case we say not. So let's run this program and see what we are getting there. So we are getting a false value. So we are saying 2 it is not equals to 2. That's not true. But let's say we put a 3 there. This is true. Then we have another comparison operators, which is a greater than. So in this case, we say 2 is greater than 3. No, 3 is greater than 2. So that's why we're receiving a false value there. So we have another comparison operator, which is less than. So we say 2 is less than 3. Yes, it is less than 3. So in this case, we'll receive a true. Then we have a greater than equals to. Greater than equals to, what it does, it says 2 is greater than y. No, is 2 equals to. So it performs two conditions or two operators at the same time. So it starts asking if x is greater than y. Is 2 greater than 3? No. Is 2 equals to 3? No. So now the full answer, it is false. No condition has been met. But if we say less than, so what it does, it will say true because one condition is met. So 2 less than 3. Yes, it is less than. So is 2 equals to 3? No, but one condition is met. So what happens there is we are having, let's take for instance this. So this will be used when I'm explaining logical operators. That's why I'm touching on this now. So for here, we say 2, it is less than 3. What we receive, okay, let me write it here, 2 less than 3. So for this, what we're getting here is a true. Then we ask again, we say 2 is equals to 3. This is what? This is false. So what the program will say, or in simpler term, what do we call this? We say this is less or equals to. So what Python will do is it will take the true value, which is we're going to say true or false. So or takes at least one value that is true. So it will go with a true value. So if it was and here, it will say this has to be true and this has to be true in order for us to receive a true value. But don't worry, I will touch on this when we do logical operators. Logical operators. Logical operators are used to combine conditional statements. Conditional statements, for example, we have an AND logical operator, we have an OR logical operator, then we have a NOT logical operator. So let's look at the AND operator. So the AND operator, what it does, it returns true if both of the statements are true. So let's look at the statements. If we have something like this, okay, let me say print so that we will be able to display this. So it will return a true value if both the statements are true. So both of these statements, this is statement 1, this is statement number 2. So these two statements are true. In this case, we will return a true value. So this is the true value we return. But if I say false there, I am contradicting the definition of the AND operator. So in this case, the AND operator said both of the condition, both of the statements have to be true. But in this case, one of the statement is false. So we will return a false. So let's run the program and see what we're getting. So it is a false. So we also can have something like false and false. False and false, it gives us a false. So this also contradicts the original definition. So this is how we use an AND operator for logical operators. Then let's look at the OR operators. Let me wipe this part. The OR operator returns a true value if one of the statements is true. So let's look at this. If we have true or a true. So what it does, one of the statements, one of these two statements is true, then we receive a true value. We ignore the other statement. So in this case, we have this true. So we will print out, it will print out the true, or will return a true. Or let's say we have a false here. So what is the original definition? It says, if one of the statements is true, then we return a true. In this case, here is this true. So it will write true again. So it will give us a true value because one of the statement is true. But let's say we have a false and a false. The original definition says one of the statements is true. In this case, there's no statement that is true. So we'll return a false value there. So this is how the OR operator work. So let's look at the NOT operator. Let me remove this part. The NOT operator, we just write NOT there. So the NOT operator, it reverses the result. It returns false if the result is true. Let's say we have the result true. Let's say my result is true after doing some computation. So let's say I want to reverse this result. I have to put a NOT there. So in a case, it's a negation. So let's run this program. So it reverses this. So this is true. In this case there, we get a false. So we get the reverse of that. So let's say true here. What it will do, it will reverse the result. So true, it gives us false. So now I'm repeating one thing. Let's say false here. Sorry for the mistake. Let's run this program. We get a true value there. What can we do again? We can say true and let's say true and a false. What this will do, it will take the result of this and reverse that result. So this is what the NOT operator is doing. It takes the reverse of the result. So in this case, when you say true and false, what is the result there? Is false. So not false, it gives us a true value. So let's try run this program. So it gives us a true because here it is false, then the reverse of false is true. So let me explain this in another way because it will be useful. I saw this with if you're gonna continue with programming, I saw this in SQL language. So it is very, very vital to understand the NOT operator. Somewhere, somehow in databases, we use a language called SQL. So this might be helpful. So when we say NOT, let's reverse everything here and get the result from there. So what I will do, let me remove the print here. So this is the final thing I'm doing just for adding knowledge. So when we say NOT here, everything has to be reversed there. So in this case, when you say not true, this is false. When we say not and, this is what? This is or. When you say not false, this in case is true. So what are we expecting to get here? We go back to the OR definition. We say OR returns true if one of the statement is true. In this case, we have this as true, and remember, we got true there. So this also is important to understand. It's just an addition or a comment I'm making. So there are two ways you can understand the not operator. Thank you very much. More videos are coming. Please don't forget to like, share, and subscribe to my channel. Thank you.